Good day. In this lesson, we do hypothesis testing. This is a chapter review, so we review the concepts learned from lessons 1 through 6 of this chapter. We see the 7-step procedure for hypothesis testing using the traditional method. In step 1, we ask for the parameter of interest. Step 2, formulation of hypothesis. Step 3, we state our assumption. Step 4, we identify the statistical test together with the details, the level of significance, and its critical values. Step 5, we compute the test statistic. In step 6, we state our decision rule. And in step 7, we give our decision. In the next slide, this is still on hypothesis testing, but using the probability value, or we commonly call it the p-value approach. The only difference is, in step 4, we no longer compute for our confidence coefficients or our critical values, but in step 5, we include in calculating the p-value. Let's start with step 1, parameter of interest. We need to ask ourselves, what is the topic all about? Basically, for this lesson, the topic can be about the mean or proportion. Like, for example, we ask for the mean age of high school students. Or if it's about proportion, we check the proportion of those who like the new enrollment system. Again, we ask, what is the topic all about? Step 2 is a formulation of hypothesis. Again, hypothesis refers to claim, assumption, an intelligent guess, and this is what we are testing. The process of testing the hypothesis is called hypothesis testing. This is a decision-making process wherein we evaluate a claim and we check whether our decision is acceptable or not. There are two kinds of hypotheses, the null and the alternative, or we say the H sub 0 or H sub O and the H sub 1. Remember that in the hypothesis, we compare our sample to the parameter. So again, we always check on the population mean or the population proportion. In the null hypothesis, we say that there is no difference. So, we state the exact value of the parameter. In the alternative hypothesis, we say there is a significant difference. Thus, they are not equal, or we say it's greater than, or it's less than. The alternative hypothesis can be non-directional, we call it two-tailed, or directional, we call it one-tailed. For non-directional alternative hypothesis, we use the sign not equal to. This is commonly seen in verbs like affect, influence, and others that do not signify a direction. The directional alternative hypothesis is also called one-tailed. It can be specific. It can be right-tailed or left-tailed. This is seen through inequality signs like greater than, less than, greater than or equal to, or less than or equal to. Its signal words are greater, efficient, improve, increase, decrease, less than, and smaller. Again, we compare our null and alternative hypothesis to the parameter, to the population. Step 3, assumption. Our assumption will be based to whether our sample size is large or small. If our sample size is 30 or more, the sample is large. But if our sample size is less than 30, the sample is small. For large samples, we state our assumption like this. A sample of is large enough. By the central limit theorem, the data is normally distributed. For small samples, we state our assumption like this. A sample of blank comes from a normally distributed population. Step 4, statistical details. How will I know what statistical test am I going to use? First, check on the sample size. Is your sample large? And is it compared to one population mean? You use the one sample z-test. Is our sample small, like less than 30, and we compare it to one population mean? Then we use the one sample t-test. But if our data is about population proportion and the sample size is large, then we use the z-test for proportions. The level of significance is stated. Otherwise, we assume the 95% confidence level for non-medical problems and 99% confidence level for medical problems. These are the critical values or confidence coefficients for large samples. For 99% confidence level two-tailed, that's plus and minus 2.58. For one-tailed, it can be negative 2.33 or 2.33 for right-tailed. The rest will follow. However, for small samples, the critical values are found in your t-table. Remember to have the degree of freedom, that's n minus 1. Step 5. Step tacitistic or the p-value. What is a tacitistic? This is a number. This is a value wherein we'll use this to compute our probability value needed for decision making. Or, in the traditional method, the tacitistic is the value wherein you're going to compare it to your confidence coefficient or to your critical values. How are we going to solve for tacitistic? We use this formula. For one sample test, t-test, this is the formula. X bar is a sample mean, mu is a population mean, S is a sample standard deviation, and N is a sample size. For one sample z-test, here's our formula. X bar is a sample mean, mu is a population mean, sigma is a population standard deviation, and N is a sample size. For one sample Z for proportions, we use this formula. P hat is the observed population. That is solved by dividing X by N. X is a number of being observed and N is a total observations. Example, we say 15 out of 100. Our P hat is 15 over 100. P sub 0 is our hypothesized population proportion. Q sub 0 is subtracted from 1 minus P sub 0, and N is the sample size. To compute for the p-value, we base it on our test statistic. Remember that we only compute the probability of the tails, whether it's one-tailed or two-tailed. If it's two-tailed, we multiply it by 2. Step 6. Decision rule. A decision rule is a guide whether we will reject or we will not reject the null hypothesis. For one-tailed test traditional method, here's how we state our decision rule. If z, that's a computed statistic, is greater than or equal to z alpha, that's your confidence coefficient or your critical value, then we reject the null hypothesis. Otherwise, we do not reject the null hypothesis. For left-tailed, we say, if z, that's our computed z, is less than or equal to z of alpha, that is our critical value, then we reject the null hypothesis. Otherwise, we do not reject the null hypothesis. For a two-tailed test traditional method, we state our decision rule this way. If the negative confidence coefficient or critical value is greater than or equal to the computed z and greater than or equal to the positive critical value, then we reject the null hypothesis. Otherwise, we do not reject the null hypothesis. For the two-tailed test, for a one-tailed or two-tailed using the p-value approach, we just state a decision rule this way. We reject the null hypothesis if our p-value is less than or equal to our level of significance. But if our p-value is greater than our level of significance, then we do not reject our null hypothesis. Step 7. Our decision. When we reject the null hypothesis, we say, thus, we reject the null hypothesis. Then we state the alternative hypothesis. But if we will not reject the null hypothesis, we state it this way. Thus, we do not have sufficient evidence to reject the null hypothesis. Then we state our null hypothesis. There are two possible errors that will be made. If we accept or rejected a null hypothesis, even if it should be rejected, then that's what type 1 error. It's failing to believe on what is true. But if the null hypothesis, which is false, is being accepted, then that is a type 2 error. That's believing on what is not true. This ends the brief introduction.